we have begun to record. Okay, the first topic is backup methods for quantitative problems. What we mean by backup methods is this. We mean that there are solution methods, backup methods, quote-unquote backup methods for quantitative problems. What we mean by this is these are solutions, techniques that can solve problems even if you don't really know how to solve the problem. Okay, so these are methods that take advantage of the fact that the problems are multiple choice. Multiple choice nature of the exam. And what they are is they allow you to solve problems that you actually don't really know how to solve. So, I mean, these are some powerful tools, because what we've seen, the reason why I feel the need to present these sorts of methods in the study hall is because, especially on the forums, but also with people submitting questions for the study hall, there seems to be this sort of one-sided priorities, where people are just studying the so-called textbook ways to do the problems, where they're just studying how you would do the problem in an answer key, or in other words, how you would do it if it were not multiple choice. Okay, so, and that is what you want to do first. Okay, so the primary way in which you should attack most problems is the so-called textbook method. Okay, when I say textbook method, what I mean is this is the sort of solution that you find. What happened? Sorry about that. This is the sort of solution that you would find in an answer key. And it's also the sort of solution that you would use if there are no answer choices, if there were no answer choices. But some students, we find, don't perform up to their potential because they basically take the entire test as if there were no answer choices at all. So, but guess what, guys? This test is multiple choice. So, if you encounter a problem that you don't know how to solve, you can take advantage of the answer choices. Okay, in the next couple of slides, we're going to show you how. This problem, we're going to introduce one method to you here. This problem should look familiar because we did this problem the textbook way during the study hall of December the 17th. Okay, so we've already shown the textbook method for this problem in the study hall of 12/17/09. So if you missed that particular edition of the study hall, you can go back and check the archived version of it. But let's say you're solving this problem. Let's say you don't figure out the textbook method. Okay, i.e. the algebra is just confusing you. You get lost in the algebra or don't know how to set this up. Again, we're not going to talk about the algebra today because that was already done in the 12/17 session, and today's focus is techniques that you can use to solve these if you don't know how to use the algebra. Well, note the following characteristics of the problem. Note, change the color here. Note the following characteristics. Okay, the first characteristic that you should note is the fact that you've got answer choices that are numbers that are very easy to conceptualize and get your hands on. So the answer choices are concrete numbers. And then also, there are relationships in the problem that you could use if you have such numbers. So here's one relationship right here, and then here's another such relationship. Those are both, if you had concrete numbers to work with, you could work through those relationships and calculate more concrete numbers. So the second aspect here that we're looking at is the problem contains relationships that are easy to work with. If you see a problem with these two characteristics, then there's a backup method that you can often apply even when you don't really know how to solve the problem. And here's what that is. The backup method in this case is plug in the answer choices and work backwards. So here's how this works. The point, again, the point of this method, before we discuss the nitty-gritty of it, the point of this method is to avoid doing algebra. Instead, here's how the method works. You pick an answer choice, you plug it in for the desired answer, work backward through the relationships in the problem, and then after you do that, if everything is consistent, then you've got the correct answer, and if there is an inconsistency, then you've got the incorrect answer. Okay, so we'll illustrate with this problem. So let me copy and paste this problem onto the next page. Here you go. Okay, let's get rid of those orange and green boxes. So let me show you how this method works. Notice you should still note back here on the previous page, if the problem has multiple quantities. This was one point we really drilled home in the 1217 study hall. If the problem has multiple quantities, you should still make organizational charts, much as you would for the textbook solution. In other words, because you're using this backup method, this is no excuse not to be organized when you solve the problem. But we are going to avoid doing algebra entirely if and when this method is successful, which is a nice enticement to using it. So here's how it works here. All right, let's start with the middle answer choice. Pick an answer choice. So let's start with C. Sorry guys. Let's start with C. Stephanie is 14 years old. Does anybody know, go ahead and type in the text box if you do know, does anybody know why you would begin this sort of process with the middle answer choice? Okay, a couple of you guys are typing. Yeah, okay, if you guys can see that in the text box, one student has written so that we can eliminate the lower or the upper half. That's pretty much the idea. It's not going to work this way on every problem, but as we work through this one, you guys will see what this means. So we should still make an organizational chart. So you've got several quantities to deal with here. In this case, you have 3 time frames, which are 4 years ago, and then now, And then 5 years from now, that's supposed to be minus 4 years. Let me change that. Okay. And then you have 3 people in the problem, which are James, Stephanie, and Kate. Okay, so let me copy and paste this stuff onto another slide. You'll see why momentarily. Okay. All right. So if Stephanie is 14 years old, then here's what we have so far in the problem. If Stephanie is 14, we can put 14 right now. Then we can start using these relationships. So James currently is twice the age of Stephanie, so we can fill in the column for James. That makes James 28. Then we can still fill in as much of the chart as we can. So if this is James' age now, we can subtract 4 and we can add 5. So 24, 33, and we can do the same for Stephanie. So 10, 19. And then notice we could start calculating things for Kate, but notice that if we add these, even without Kate, this sum is already greater than 51. So that's pick an answer choice, and then in this table we're doing these next couple of steps. Plug it in, work backward. So let me point to those in this particular chart here. Step 2 is plug the choice in. That is happening at this place right here. And then everything we're doing in orange in this chart is finding the relationship. So that's working backward. And then notice that this is an inconsistency. This is an inconsistency right here. Because the ages are supposed to add to 51, this is already greater than 51. So, therefore, this is the wrong answer. Okay. Notice we didn't need any algebra at all to figure this out. None. And moreover, what else does this mean? Not only is this answer wrong, but which answers are also wrong based on this result being greater than 51. Okay, yeah, a couple of you are typing this in. Yeah, everything that is greater. So because the middle choice is incorrect, we can tell that this choice is too big. So the bigger answers can also be eliminated. So based on this, we've crossed off 3 choices already. 14 is gone, 20 is gone, and 24 is gone. So pick an answer choice. This time let's start with 10. Stephanie is now 10 years old. So what we're doing is let's start with choice B this time, which says that Stephanie is 10 years old. Then, again, plug in, and then work backwards through the relationships. So Stephanie is 10, James is twice as old, that's 20. You can fill in the rest of these: 4 years younger, 5 years older, 4 years younger, 5 years older. And then 4 years ago, Stephanie was 3 times as old as Kate, so Kate would have been 2. And then we can add 4 years to figure out how old she is now, and add 5 more years to figure it out. So then we check. The sum is 51 years. And this time, everything is perfectly consistent. The sum is 51 years. The sum is supposed to be 51 years. So everything is perfectly consistent. Correct answer. Okay, so does everybody follow this method? Smiley face if you follow what we've been doing here. There's a couple of other pieces of insight being typed into the text box. There are some shortcuts that you can use as well. But, I mean, remember when we're using this method. I mean, this method is used when you don't really have enough intuition to figure out the textbook type solution. So if you can come up with this sort of stuff here, that's great. But remember that this solution type plays a special role as a unique backup that you can use when you don't really know how to do any of this stuff. So, but notice the characteristics of the problem. This is a takeaway. This is generally what problems look like where you can do this sort of thing. You have answer choices that are concrete numbers, and the problem contains relationships that you can work with. The relationships might be stated explicitly like they are here, or they might be implicit in the information they're giving you in the problem. Like if the problem contains a special geometrical figure, for instance, then you'll have to know the relationship without being told. Plug in the middle choice, judge it, plug it in. If it's inconsistent, eliminate as much as you can, then keep plugging in. No algebra required. Like in this problem, this is a pretty formidable algebra problem. We tackled this on December 17th. Most attendees at that study hall did not solve this problem correctly in time because using a single variable here is somewhat challenging. Some people tried to set this up with 3 variables, which is just usually not doable in the amount of time that you have. But notice that when you use this method, it reduces the problem to grade school arithmetic. It's very nice. But you have to think to do this method in this first place. Okay, smiley face if you guys are ready to try one yourselves. Okay, I notice someone is typing something in the text box. Okay, if there's a question, someone's typing. Okay, there's no more typing. All right, so here's a problem. I'm going to put you on the timer. If you know the textbook method for this problem, you can use it. If not, the goal is to get you accustomed to this sort of solution as a backup. This problem is from GMAT Prep. Okay, give it a shot, and here you go. I'll give you about 2 minutes to do this one. And I'll do Again, guys, read the words that I typed in the window. There are A through E options in the top left of your window that you should click on. Okay, do not type your answer into the text box, please. Okay, guys, I only have answers from 7 of you, and 6 of you are wrong. Let me give you about 30 more seconds to try this. But at the end of 30 seconds, I expect that everybody should have some sort of answer indicated, even if that answer is a guess. Remember, guys, don't type your answers in the text box. Please indicate them with the buttons at the top left, like I've been saying. Thank you. Okay, everybody give me some sort of answer, even if the answer is a guess. Okay. 3, 2, 1. Okay, here are the answers. Pretty decent spread here. I think you guys know the hypotenuse is not 8. That's a good thing. Some of you still didn't answer the question. I'm going to go into like scolding lecture mode here for a second. But if you are one of these people, you're going to die when you take this test. We gave you about 3 minutes to do this problem. 3 minutes is a lot of time. Okay. You cannot afford to do this on the test. Okay, in other words, you must guess within a decent amount of time, even if your guess is random. You know, because again, 3 minutes is a very, very large allocation of time for this problem. So if any of you are still sitting there staring at it after that long, you got to remember to keep a perspective on this. Okay, so be aware, if you are, one of these 6 people is me, so that means there's 5 of you in the room who don't have an answer indicated here. If you are one of those 5, just be aware that that is a habit that's not going to work on test day. You got to give answers to these things within a decent amount of time. Okay, let's take a look. It turns out that we got 2 answers here that are sort of neck and neck in the popularity contest. So let's use the backup method. I mean, yes, there's a textbook method because there's always a textbook method. But let's go ahead and let's plug in the choices. Because again, we've got concrete numbers. Answers equals concrete numbers. And there are definite relationships if you know the 45, 45, 90 triangle. So let's plug choices and work backwards. Okay, so which choice do we want to try first? Go ahead and enter in the text box, please. Okay, we want to try C first. Let's try C first. So let's start with choice C. That's the middle choice. Okay, if we start with choice C, let's draw ourselves an isosceles right triangle. Isosceles right triangle looks like this. 2 equal sides is a 45, 45, 90. And then here are your congruent sides. So we're looking for the hypotenuse of the triangle, not the side length. So if the hypotenuse is 8 rad 2, I'm going to draw the square root sign. If we insert 8 rad 2 for the hypotenuse, then let's see what happens. Well, the relationship is that the hypotenuse, the ratio of the hypotenuse to the legs is rad 2 to 1. So the ratio of hypotenuse to leg is rad 2 to 1 in this triangle. Again, I gotta get the square root sign on there. So that means in this case you can just sort of look at this. You could set up a proportion if you wanted to, but notice that this is just a multiple of 8 times this ratio. So that would mean that these guys on these other sides are going to be 8 each. That did not work out right. Okay. This is 8. and this is also 8. So I think you'll notice this was a very popularly chosen answer here, but this is the wrong perimeter, because this is not 16 plus 16 square root of 2. In this case, the perimeter works out to 16 plus 8 rad 2, not 16 plus 16 rad 2. So that's too small. And again, you don't really need any fancy algebra to figure this out. You just need, I mean, you do need to know the facts for the 45-45-90 triangle, but beyond that, you don't need to do you don't need to know how to do much else. But since this is too small, we know that we can eliminate 3 options here. We know that we can cross off this, and we can cross off the ones that are smaller. So, okay, one thing I noticed about this problem was that absolutely everybody who answered this problem really fast put C. Like, here are our problem statistics. Okay, I mean, there's only 5 of you, but these were the first 5 people to answer the problem. Like all of you guys who put answers down in the first 45 seconds or so, you were all wrong. You guys all put C. So what this means is you're perhaps not being diligent enough in solving the problem, and you should try methods like this. Does everybody follow that C is the incorrect answer, and we can prove that by plugging in? So smiley face if you guys follow. Okay, good. I'm seeing some smiley faces, especially from people who picked C. I'm seeing one non-smiley face. If that's you, then go ahead and type your question into this text box here, and I'll try to incorporate the answer into the show here. So, but let's try the next answer choice. So here's the same problem. Okay, here's a new slide. So we've eliminated those choices, so now let's go ahead and try 16. At this point, you could notice, as an aside, let me note the following. You could notice that 16 square root of 2 is exactly twice the size of the answer we just tried. Therefore, you'll get a perimeter that is exactly twice the perimeter we just got, which would be, that would be 16, because the perimeter we got last time was 16 plus 8 square roots of 2. So if we plug, and that was, we got that from plugging in 8 square root 2. So if we plugged in a number that is exactly twice that big, we would get a number that is twice as big. So that would be 32 plus 16 rad 2. That's also a wrong answer. So you can also realize with that sort of reasoning that E is incorrect. But if not, let's just go ahead and try D. Because again, the point of this method is that you don't really have to understand any of this intuitive stuff. All you really got to do is just keep plugging the choices in and look at what's happening. So let's try plugging in choice D. Let me copy and paste as much of this as I can here so that we can save some time. Okay, in this case, let's continue with choice D. So if we'd add choice D there, then that's going to be, hold on, I got to erase these little pieces of picture. It's going to take me a second. Okay. Okay, if we put in choice D, then that gives us 16. That means these are no longer 8. These are now 8 square roots of 2. We got to figure that out. This time we've got to do a little bit of math to figure this out. We have to divide, because the ratio is still square root of 2 to 1. So we're going to have to divide by square root of 2 to figure out that side. So 16 divided by square root 2. In the text box, someone tell me, how do you divide by a square root of, how do you divide by a square root? A reminder from anybody? Someone's saying square the top and bottom. I think you might be using the wrong words for the right concept. You can't literally square them, because you'll get a number that's the square of your original number. And that would be like saying, I mean, you can't just randomly square a number. If you were solving an equation, then you would just square both sides, but that's different. When you solve an equation, you can do stuff that changes values as long as you do it to both sides. But here, yeah, make sure you know it's not squaring both sides. I mean, that would be like saying that 3 is the same as 9. The way to simplify this expression is to multiply by the same square root that's already on the bottom, but on both sides of the fraction. Because remember, when you're working with one expression like this, you have to preserve the value. You can't just do stuff that'll change the value. You can't just double it or square it or anything like that. So no, you don't need a conjugate here. A conjugate is what you do when you've got a binomial in the denominator. You can check out the strategy guide with square roots in it for that. But no conjugate's necessary here. We're just taking the 16 and we're dividing it by rad 2. Because here's the ratio. So this quantity in the denominator works out to 2, and so 16 divided by 2 is 8. So ultimately you wind up with 8 square roots of 2 on both of these sides. 8 square root 2. Sorry it's taking me so long to make these square root signs. So in this case, the perimeter does work out to what we want it to be. The perimeter does work out to 16 plus 16 square roots of 2. And so we are happy. That's the answer we want. Okay, I noticed a couple of you are typing in the text box, so I can wait and see what you're doing. Okay, one of you is typing. The textbook method, there is a way to do it on the forum. It's something I could do at the end of this study hall if we have the time, but it's not the theme of today's study hall. The question is, what's the textbook method for this problem? I can do it at the end of the study hall if there's time at the end of the study hall. I don't really want to do it right now because it's not the point. The point of today's program is to present these backup methods. So I'll table that issue for now, and then if there is time at the end of the study hall, then I can go ahead and quickly show you the textbook method for this thing. Looks like one other person's typing a question. No, okay, so smiley face, textbook method again we're not worried about for the moment. Smiley face if you understand this backup solution to this problem. Again, here's why you can use it. It's because there are concrete numbers and you have definite relationships. Notice the difference in this case, the relationships are inherent. I mean, you're dealing with an isosceles right triangle, so you have to know those relationships, as opposed to the previous problem where the relationships were just handed to you. So that's the only thing that's really different here. But then you can plug the choices in. If we plug in the middle choice first, we wind up getting something that is too small. So we go bigger, and we wind up with just right. Okay. Question in the text box, how do you figure out this? This is something you just have to know. This is a basic fact about 45, 45, 90 triangles. That's just something, that's a fact that you've got to know. It's kind of like knowing that the area of a circle is pi r squared. It's just one of those basic pieces of factual knowledge that you're expected to have. There are not a ton of those, but you are expected to know 45, 45, 90 triangles and 30, 60, 90 triangles. In this case, you actually could use the Pythagorean theorem. Yes, that is true. Although in the case of a 30, 60, 90 triangle, you cannot use the Pythagorean theorem because it's not possible. So let me just put a quick slide up for that. Okay, for a 45, 45, 90 triangle and for a 30, 60, 90 triangle. For a triangle that's 45, 45, 90, you've got two equal legs and you've got a hypotenuse. So this is a leg. This is another leg, and this is a hypotenuse. In this triangle, leg to hypotenuse equals 1 to 1 to square root 2. And that's just something you have to know. Much like you would just have to know that the area of a circle is pi r squared. In this case, the Pythagorean theorem could tell you this. On the other hand, if you encounter a triangle that has 30, 60, 90 degree angles in it, then the Pythagorean theorem absolutely will not save you. So this is the 60 degrees. This is the 30 degrees. Let's call this, I don't really want to assign variables where we don't need them. But these are all different sides in this case. So if we label them, this is the short leg. This is the long leg, and this is the hypotenuse. In this case, the short leg to the long leg to the hypotenuse is 1 to square root 3 to 2. And again, this in the Pythagorean theorem will not tell you this. So this is a piece of factual knowledge that you got to have. If you don't own our geometry strategy guide, you should probably pick up a copy of it, because that's the place where you can get all this information in one place. And you can get it from a geometry textbook as well, but the geometry textbooks will be polluted by a ton of stuff that's got nothing to do with the GMAT. So in this case, the Pythagorean theorem will absolutely not work. So yeah, this is just stuff that you've got to know for plugins, or whether you plug in or whether you don't. Okay, let's move on to the next backup method. Let's take a look at this problem. This problem's different from previous problems because the answers are not concrete numbers. So instead, again, we're not doing textbook methods in this part of the study hall. These problems all have textbook methods because all problems have some sort of textbook method. But that's not the point of today. So just FYI. Let's take a look at this problem. Here's some characteristics that this problem has. Characteristics of the problem. This is different because the answers are not concrete numbers, so we're not going to be able to use the last method here. In this case, we've got unknown quantities that are still unknown, even if you successfully solve the problem. So like in this case, we don't know what these are. We have no idea what the rectangle's length is, and we have no idea what the rectangle's width is. And even if we solve the problem, we still don't know what they are. So, important now. Even if we can solve the problem, we still don't know what these are. So, what you can do is second backup method. Backup method number 2, plug in your own numbers. Okay, this is what's called, this is in our strategy guides. It has a name, it goes by the name of the Vic method. This goes by the name of the VIC method in the strategy guides. But what I want you guys to know is that the name VIC is sort of unnecessarily limiting here. Because VIC stands for variables in the choices, and this doesn't have any variables in the choices, and we can still do it this way. So this is the point. The point is when you've got unknowns that are still unknown even at the end, you can just pick them yourself. So here's the way it works. Here's the steps. First thing you do is you figure out which quantities are undetermined. Then you just make up your own numbers and plug them in. Then you solve the problem. And then you have to check the answer choices. And then repeat if necessary, which will in this case you won't have to repeat, but we'll show you a problem in a second that you might have to. Okay, so in this case, you figure out which quantities are undetermined. In this case, it's everything. It's just length, width. So let's go ahead and make a chart. And notice we have a before and an after. So this is a nice situation for making a chart because we have 2 situations and 3 quantities. We have length, width, and area. And then we have a before, and we have an after. So you could use variables for this. There is a textbook method, but notice that you can just pick your own numbers. So in the text box, what is probably the easiest number to change by increments of 10%? 10% and 20%. Yeah, 10 is great. It's even better than 100 because 100 will make numbers that are... Because if you pick, the problem with picking 100 for length and 100 for width is that your numbers are going to get kind of big. I mean, you know, you're going to have an original area of 10,000, which is not the world's nicest thing. In this case, we can just pick 10 for both of them. I mean, it's not the only choice that'll work, but it's probably the best choice because then you'll get an area of 100. So let's just pick these. Again, these are certainly not the only choices that you can use, but they are perfect for this problem. So make up your own numbers. Here are the numbers that we make up. These numbers right here. Okay. Now that you've got those numbers, let's just do what's in the problem. If we increase the length by 20%, then we get a new length of 12. If we decrease the width by 10%, we get a new width of 9. And then 12 times 9 is 108. So the area has gone from 100 to 108. This is a change of 8%. This is an 8% increase. So, the only choice that works is D. There it is. Again, there's certainly a textbook method here, but you don't need to use it, and the point of this study hall, again, in particular, is to illustrate the methods that are not textbook. So, okay. Smiley face if you guys understand what's happening here. All right, so try your hand at the following problem. Give this a shot. I'll clear your answers. Again, please don't type answers in the text box. Please indicate them with the choices that are up at the top left. Put you on a timer and have fun. Okay, that's the expiration of 2 minutes. About half of you still haven't answered the question yet, so I'll put another 20 seconds on the clock. In those 20 seconds, go ahead and indicate some sort of answer, please, using those answer indicators that are up at the top left. Okay, please, if you haven't answered the question yet, indicate something. So a little bit better here. Here are the answer statistics right there. This time, unlike previously, we do have a consensus, but there's still only about half. This is out of 14 respondents. We have 7 correct and 7 incorrect. So let's take a look. Again, there is a textbook method, but that's not the point of today. Here's the problem. What I want to illustrate here is that note, this time they're almost telling you to do this. Like if they tell you for all x, then that means this technique will always work. Like if a problem uses for all x, or in terms of, then you should almost always be able to insert your own numbers. Because think about what this means for a second. This means that for any x you can possibly pick, this should work. So if you pick an actual particular choice of x, then this has to work. So let's just pick a totally random x. Because according to this problem, the correct answer should work for any and all values of x. Therefore, let's pick our own value. Okay, so let's do that. Here are the steps of this method again. Figure out which quantities are undetermined. Make up your own numbers and plug them into the quantities. Let's get those highlights out of there. Okay. So in this case, the quantity that's undetermined is x. So even if you solve this problem all the way through, you're still not going to get a number for x. Okay. So let's just make up a number for x. I mean, there's nothing, unlike the last problem, we had some pretty strong indicators of what to pick. Like in this problem, we had increments of 10%. We had 10% and 20%, so 10 was a natural choice. Here, there are no incredibly strong indicators one way or the other of what to pick. So let's just pick a random number, like totally random number. Let's just pick x equals like 5. So now notice the problem becomes for which of the following functions is f of 5 equal to f of negative 4? Because if x is 5, that's what this winds up saying. It says that f of 5 has to equal f of negative 4. So what this means, instead of dealing with these sort of frustratingly abstract variables, now we can just plug 5 into f and plug negative 4 into f and just see what happens. Okay, so everybody give me a smiley face if you understand that so far. Okay, so the faces I see are all smiling so far. This is good. Okay, let's move this stuff a little bit. So let's do that. Solve the problem and check the answer choices. In this case, solving the problem pretty much is checking the answer choices. So let's do that. Again, let's make a chart. It helps to stay organized. F of 5 is one of the things we're finding, and then f of negative 4. Let me make my print a little smaller here. One of the quantities we're finding is f of 5. And the other thing we're finding is f of negative 4. So with choice A, f of 5 is negative 4, and f of negative 4 is 5. Those are not equal, so A is wrong. With B, f of 5 is 1 minus 25. F of negative 4 is 1 minus 16. Those are not equal. With C, f of 5 is 25 minus 16. And f of negative 4 is 16 minus 25. Those are not equal. Sorry, I have to type them. So it's 6.5. With D, f of 5 is 25 times 16. And f of 4 is 16 times 25. Now notice we're not done. We can't stop here because we have to check all the choices. Because it is possible to get a coincidence, unlike last method. So we do have to keep trying here. This is going to be 4, this is going to be 5 over negative 4, and this is going to be negative 4 over 5. So there is only one choice that works in this case. The others don't work. It's rare, but when you do use this method, it is possible to have a coincidence. So you do have to check all the choices. But no, okay, so remember, this is very important. You do have to check all the choices, even if you see the answer you want. Because these are your numbers. These are not their numbers, and so it is possible to create a problem that creates a coincidence. If this happens, then that's when you repeat. If you do see the correct answer more than once, you keep the answers that work, you throw away the ones that don't forever, and then you just work the problem again with more numbers. Okay. Smiley face if you guys understand. Yeah. Well, so someone in the text box, if you pick 0, then you can still eliminate E. Because if you pick 0, then the left-hand choice would give you 0, 1, which is 0. And the right-hand choice would give you 1 divided by 0, which is undefined. But they're not equal. So 0 does not equal undefined. So you're actually still fine if you pick 0. Okay. In the text box, we see how about x equals 1/2. That's not a good choice. Because if you can look at this and tell that 1/2 is about the worst number that you could pick. Because if you pick 1/2, then you won't eliminate anything. The point is that you want remember what you're trying to do here. You're trying to eliminate answer choices. You're not trying to create coincidences. In fact, you want to stay away from numbers that'll create coincidences. If you pick 1/2 for x, then all 5 of these choices will work, and you won't eliminate anything. So, yeah. But again, you don't need to put too much thought into the numbers that you pick. I mean, if there are not obvious choices of numbers, like these choices are pretty obvious. Like, oh, I want to take 10% of something, I want to take 20% of something, let me try 10. If it's a problem like this problem is not throwing out any really obvious hints about what numbers to pick, so don't think too hard about it. Let's just try 2 and 3 and 4 and 5. And just see where it goes. Okay, one more question. The question is, if this says for all x, then why are we picking a specific number? Remember, this is a multiple choice question. Okay, we don't have to do algebra here because this is multiple choice. If we can do anything that will eliminate the 4 wrong answers, then we're done. I mean, remember, this is a multiple choice test, and a lot of people approach it as though we're not. But if this says for all x, what that means is that any particular x that you plug in has to work. So when we choose 5, there's nothing special about 5. I mean, 5 is not a unique solution to anything, if that's what your question means. But if any of these statements are false when x is 5, then they're wrong because they're not true for all x. I mean, this literally has to be true. It has to be for all x, including this random one that I happen to pick. So it's a very powerful technique. And again, it obviates the necessity of doing anything. Yeah, you can pick 1. That'll also work. Like I said, there's nothing special about picking 5. Although the good thing about picking numbers like 3 and 4 and 5 is that x and x squared are different. Like I would stay away from picking 1 or 0 here, just because a and b become the same thing if you do that. So remember, the goal here is not to make the answers the same. The goal here is actually to differentiate the answers from each other, so that some can be eliminated and some cannot. So 1 is you'll get away with it, it'll work here, but it's a questionable choice because it makes these 2 identical right away. So if the answer choice were A or B, then you would not be able to tell which one it was. So with any other choice like 2 or 3 or 4 or 5, though, you're good. Okay, any questions? If not, let's move on to one more method. Okay, so these 2 methods, plug in your own numbers is the second. Plug the choices in and work backwards is the first. One thing you've probably noticed, or at least I hope you've noticed by now, is that both of these choices require the question to be multiple choice. If the question is not a problem-solving type question, then these methods simply aren't going to work. So for data sufficiency, we need to approach it from a somewhat different angle, and that's going to be the topic of the next method. But let me try this problem. Let me just throw this at you and see how you do. So carte blanche, I'll give you 2 minutes and small change here. This is a data sufficiency problem, so take a shot at it. Again, same thing, answer choices in the corner. Okay, guys, let's wrap this up. I'll give you 20 more seconds in which to pick an answer. By the end of that timer that's on the screen right now, try to have something, please. Okay. Guys, remember, same deal with the answer choices. The answer choices are in the top left corner of your window. They are not, please don't type in the text box. There are buttons that you can press on the top left of the window. That includes you guys who are typing me messages with the answers in them. Okay, so we are all over the place here. Among people who have answered the question, there are still a lot of people who are not answering the question. But there's not really a clear consensus on anything here, which is good. Let's go ahead and review this. What I'm going to do is show you the third backup method, which is another plug-in method, but it's a data sufficiency plug-in method. So here's the problem. Third and final backup method that I'm going to show you today is data sufficiency number plugging. Okay, here's how this works. The difference, there's a huge, major difference from the previous two methods, which is that this is data sufficiency, which is predicated on whether a statement is sufficient or insufficient. It's not problem solving. So unlike problem solving, you can't just plug in a number or two and see what happens. You actually have to try a spectrum of different numbers here. So the way it works is you have to plug in an array of different numbers. Okay, now there's different ways to do this, but in some problems it could be systematic, like if there's a pattern. It could be exhaustive if there are only a limited number of possibilities. It could be extremes if you get an inequality. And it could even just be different number types. Could be like positive, negative, fraction, etc. if it's number properties. But the point is that you can't, the point is that you have to plug in. You have to try multiple plug-ins. This is a stark contrast to the other kinds of number plugging, because with the multiple choice questions, if you pick one well-placed number or set of numbers, you're done. You get an answer. But here, this is sufficiency. It's impossible to tell sufficiency without plugging in multiple possibilities. Then, basically, you just answer the question for each possibility. And then if you ever get two different answers, then that's insufficient. If you keep getting the same answer every single time, then that's sufficient. That's pretty much how this works. So you plug in an array of different numbers, answer the question for each possibility, and then you just see what happens. So let's go through this. Let's do statement 1 first. Okay. In this case, this is a systematic. We can plug in a systematic list of numbers. Because what does this mean? If square root of n is an odd integer, this means that n is an odd integer squared. So that means it's very easy to come up with a systematic list of possible n's. So n could be 9, it could be 25, it could be 49, it could be 81, it could be 121, it could be 169, etc. This is a lot of plugins, but you guys get the idea. You make a smiley face if you understand where this list comes from. Okay, this is a list, a systematic list of numbers that satisfy this statement. So what we're doing then is we're just going to do the division. We're not going to get all smart with algebra and stuff. We just find the remainder when n is divided by 8. So the remainder when n is divided by 8 is, in each of these cases, this will give you 1, this will give you 1, 1, 1, 1, 1, 1. I definitely see a pattern here. So, and since this is also a very important point, divisibility is based on patterns. So I can trust this pattern. So I'm going to say that's sufficient. Notice we're not 100% sure of this, because by plugging in numbers, you can never be sure that there's not a different remainder right around the corner. Somebody asked, what about 7? 7 is irrelevant because 7 doesn't satisfy this statement. I mean, the square root of 7 is not an odd integer. So 7, we don't care about 7. It doesn't satisfy the statement. Smiley face if that makes sense to you. I mean, you have to obey the statement. You can't just plug in random numbers anymore. You have to obey this. So we're going to call that sufficient based on overwhelming pattern evidence here. So here's our grid, AD, BCE. We just killed BCE. Okay, statement 2. Again, this is a very systematic list that we can make. Just all the numbers that give you that remainder. So, again, we can make a systematic list of numbers. Because n is 1 more than a multiple of 4. That's how you get this to happen. You take a multiple of 4 and you add 1 to it. And if you don't figure that out, you can just figure it out by pure trial and error. But the ends that satisfy this statement are, it's got to be greater than 5, so we start with 9. Here's the first few of those. Then we're doing the same thing. We're still finding out the remainder when n is divided by 8. So if we divide these numbers by 8, if we divide 9 by 8, we get a remainder of 1. If we divide 13 by 8, we get a remainder of 5. Do we have to keep going? Yes or no in the text box. Like here, notice we kept going until the sun starts to set, right? I mean, we're plugging in. You may not need this many plugins to start trusting the problem, but there's a clear pattern here. As soon as you get this, though, you are done. You don't need to keep plugging in, because this is absolute proof of insufficient. So notice the marked difference here. You can't really prove insufficient. You can't really prove sufficient. All you can do is just keep getting the same answer over and over and over again until you decide to surrender. But insufficient, you can prove based on, as soon as you get 2 different answers, you've got solid proof. It's irrefutable. So that's how it works. It's basically you just pick a list of numbers, answer the question each time, and then see if it's sufficient or insufficient. Now notice the one thing I want to point out, I'm going to have an especially tricky thing for you in a second here. But if you ever get two different answers, then you are done. So note the difference here. There's a question in the text box that says, do we just ignore the beginning of the question stating that n is an integer? No, we don't. I mean, we have to pick things subject. I mean, we have to obey that condition as well. So notice that's what we're doing. I mean, all the things we're picking here are integers. If you obey statement 1, then you're going to be an integer anyway automatically, so it's not even really worth worrying about. But yeah, you do have to pay attention to that. In this case, that's more bookkeeping than anything else, because they're not going to give you divisibility problems with like decimals and fractions. They don't do that. What I want you to notice here is this. Okay. You can absolutely prove that a statement is insufficient with plugins. Okay, sufficient though is just surrendering after you fail to get insufficient. So therefore, what you're trying to do, basically, you are trying to get insufficient by plugging in. In other words, your efforts are directed towards trying to find two different values. Because if you do, then you are done. If you fail to get insufficient, then you just capitulate. Like here, we tried all these different numbers, and we could not get insufficient. We kept getting 1, 1, 1, 1, 1, 1, 1, and we could not get a second value. So we're going to say, okay, fine, it's sufficient. But here, someone said, why did you pick prime numbers? This problem has nothing to do with prime numbers. Some of these are prime, some of them are not. That's not the point. And actually, none of these are prime. So, yeah, we're just obeying the conditions in the problem. Remember, you don't want to overcomplicate the issue. Like, if the problem isn't about prime numbers, then you don't want to bring that into the you don't want to bring that into it. So, someone is saying, at what point can you stop picking numbers? I have another very tricky, delicious example for you that's gonna hit home on that. With the statements not contradicting, again, we're not doing them together right now, so in this problem that's not a factor, but what the question is in the text box, you can see it. The question is, what about the fact that statements don't contradict each other? What that does is that guarantees you that there will be numbers in both lists. And so then if you have like C versus E, you can just look and see which numbers are in both lists. So, okay, let's move on. We're starting to run a little bit low on time. This is not a whole problem. I'm just giving you a data sufficiency with one statement. Okay, so remember, your goal here, this problem is sort of obnoxious. Warning, this problem is not easy. Okay. This would be a very high level problem if it were to show up on the test. So if you get a little bit lost, this is like the extra credit part. If you get a little bit lost here, this is fine. Okay. Remember, you are trying to prove when you plug in, you are trying to prove that the statements are insufficient. Okay, so let's do this. P is n squared minus n plus 41, comma, where n is a positive integer. Okay, so let's plug in values. So let's make a list. Okay, if we plug in n, then we can find all the p's. So that's what we'll do. And then we'll answer the question. So n is just any positive integer, so let's just start grinding those. If n is 1, then p is going to be 41. If n is 2, it's 43. If n is 3, it's 47. If n is 4, it's 53. If n is 5, it's 61. Okay, let's try these. If you try these, you'll find out that all of them are prime. Okay, if you give this a shot, that's prime, so is that, so is that, so is that, and so is that. I'm not sure why there's a double S here. Let's fix that. Okay. At this point, you might be tempted to throw in the towel. Okay, but there's a difference. There's a very significant difference from last time. And that is that primes don't follow patterns. Okay, the last problem was about divisibility and remainders. Those were pattern-based. So you know you can trust the pattern. After a few examples. In other words, divisibility is like the remainders just repeat over and over and over and over and over and over again in exactly the same way all the time. So if you understand that, then nothing new is going to happen here after a while, because this stuff is all very systematic. It's about remainders and stuff like that. On the other hand, see, this problem is about primes. Primes don't have patterns. Okay, this is a significant difference that you got to pay attention to. This problem, on the other hand, is about primes, which don't have patterns. So, you should continue to investigate. All right. So what are we trying to do? I mean, right now we have a whole bunch of yeses. So someone type in the text box, what is our goal at this point? Since we have like 1 million yeses, what are we trying to accomplish? Well, we're trying to get a no. Okay, because at this point, any more yeses don't help at all. So try to get a no. Well, as one of our posters has pointed out, there's one number which will give you a no pretty much automatically here, and that's 41. Because then P is 41 squared minus 41 plus 41. And so that's no. And I mean, you don't have to think of 41 itself. If you have any multiple of 41, then you'll get a no. Because if you plug in any multiple of n, any multiple of 41 for n, then you'll be able to factor a 41 out of this expression. So that's, sorry, P is not 41, P is 41 squared. And that's not a problem. So the difference here is you absolutely will not happen upon this solution by just plugging stuff in. If you guys have a question, go ahead and type the question into the text box, please. So no, well, these are not randomly assigned. I mean, you can't randomly assign values because you have to obey this condition. So if you pick a random p, then the chances that it's going to obey this condition are very, very, very small. But notice that this is given in terms of n, where n is a positive integer. So what this means is that you can pick any whole number for n, and then just do this, and that's where you'll get p. So it's not, the n's are essentially just random positive integers, but the p's are not random at all. The p's have to come out of this formula. So, okay, a couple of people are typing questions in there. Well, someone says, what about problems that don't explicitly state integers? Well, you can't, I mean, you can't assume anything that you don't know. If a problem doesn't state that something is an integer, you can't just assume that it is. But if they, again, if they give you problems about divisibility or primes, they will give you integers. They will not ask you questions dealing with divisibility and primes with numbers that are not integers. It just doesn't happen. So, be aware of that. They're not going to, they will be very, very clear in stipulating what has to be true. And if they don't stipulate something, you just don't know it. So, okay, the question, again, the 41 is not special. Okay, the 41 is a function of this problem because there's a 41 here. Okay, if you're thinking that you can just plug in 41 on any problem involving primes, I mean, 41 is not a special number. So what you have to do is, there's no magic bullet. There's no special numbers that you can always plug in, which is in fact why these problems are hard, because it's never the same numbers. Like you have to look for signals in the problem. Like in this case, the signal in the problem indicates that 41 is a good choice. In the next problem, there's going to be something else in a different sort of way that'll tell you to plug in something else. It's never going to be the same thing every time. You got to. That's why you have to study. You have to learn what they can give you that'll tell you to plug in what. It's pretty much different every problem. So, okay. So we are a couple of minutes past 9 o'clock, so here's the deal. We are going to have to defer these other topics that are listed here. We're going to do this next time. So let me notate that. We're going to have to defer these topics until the following study hall. And then we'll also do some verbal in that addition. So these topics will be deferred to the 218 study hall. Yeah, we'll do equations with absolute value, and then we'll also do some more on inequalities, and perhaps some verbal as time permits. Okay, but please go ahead and keep submitting stuff, and we will eventually get around to it. So there you go. 3 backup methods for you today. And I mean, today's study hall is probably the most useful study hall you're going to have, because these question, where can we find these notes? You can't find the notes, but you can find a recording of this session. It'll be posted on the Manhattan GMAT website by Monday or Tuesday. This whole session has been recorded. So you should be able to find that. But the first backup method is plug in the answer choices and work backward. Second backup method is pick your own numbers. And the third backup method is number plugging for data sufficiency, which is entirely different. So these three methods together, if you apply them far and wide, these can solve, you know, close to half of what you're going to see in the quant section in some way or another. They're extremely powerful methods. So especially in problem solving, you can solve up to half of the problems in problem solving by doing some sort of backwards plugging method. Extremely powerful. Okay, what we're going to do is we're going to cut it at this point. We are over by about 5 or 6 minutes, so we're going to stop. And thanks for attending. If you want to type some super quick questions into the text box, you can do that. I'll try to answer them, but we got to get logged off of here in the next couple of minutes. So this will be recorded. It has been recorded. The recording will appear online soon enough. The previous recording does exist. There were some technical difficulties with it, so we'll see about getting the previous study hall up there. But this one should be up there by a few days from now. How much do you spend on one math question? You should always try to answer the question within 3 minutes, even if 3 minutes should be an absolute upper limit, because otherwise you're going to die. Okay, let's get out of here. You guys can quit the application. You can just quit it. You don't need to do any special keystrokes or anything like that. You can just close the application. And if you don't do that, I'll start removing you guys from the room in a couple of minutes. Thank you for attending, and I will hope to see you next week.